The integration of sine x cosine x is one of my favorite problems because it has many solutions, each of which involves using different integration techniques and possibly some knowledge of trigonometry identities to solve the problem. In this video, I will be showing you some of the ways in which you can solve the problem. We will solve the problem using the technique integration by substitution by letting x is equals to secant x, which is the same as 1 over cosine x. We differentiate u with respect to x. This gives us secant x, tangent x, in which multiplying both sides by dx, we get du is equal to secant x, tangent x, dx. My secant x, tangent x can be rewritten as follows. My secant x is 1 over cosine x, tangent x as sine x over cosine x, and simplifying them we get sine x over cosine square x dx. We transform my sine x cosine x into the following. We have cosine cube x sine x over cosine square x dx. My sine x cosine square x dx as du. How about my cosine cube x? My cosine cube x is basically the same as 1 over cosine cube x, which gives us just 1 over u cube du. And this can be rewritten as in the form of indices u to the power negative 3. We can now evaluate the integral. We get u to the power negative 2 over negative 2 plus c. And last but not least, we substitute my u as 1 over cosine x, and we get the following, which is negative half 1 over cosine x to the power of negative 2 plus c. This is the same as negative half sine square x plus c. And this is the answer to the integration of sine x cosine x dx. This solution involves the integration by substitution, letting u is equals to sine x, and we differentiate u with respect to x. This gives us cosine x, in which multiplying both sides by dx we get du is equals to cosine x dx. Now my problem can be rewritten as sine x, which is u, and my cosine x dx as du. And the integral of u du is just basically u squared over 2 plus c. Last but not least, substitute u as sine x, and we get the final answer as sine square x over 2 plus c. We can solve this problem by using the trigonometry identity, the double angle formula of sine 2x. We know that sine 2x is equals to 2 sine x cosine x, in which if we were to make sine x cosine x the subject, we get sine 2x over 2. So hence we can transform this question into the integral of sine 2x over 2 dx. We take out the constant half. We get half times the integral of sine 2x dx, in which evaluating the integral sine 2x, we get the negative of cosine 2x over 2 plus c. And this is the final answer, which is negative 1/4 cosine 2x plus c. We can solve the problem by using the technique integration by substitution. We let u be, in this case, cosecant x, and my cosecant x is basically just equals to 1 over sine x. We differentiate u with respect to x. Next we get the following: negative of cotangent x cosecant x, in which multiplying both sides by dx we get du is equals to the negative of cotangent x cosecant x dx. We further transform the cotangent x cosecant x into as follows. My cotangent x is just cosine x over sine x while my cosecant x is basically 1 over sine x dx. Simplifying further, we get negative of cosine x over sine square x dx. My sine x cosine x can be transformed into as follows: the negative of integral negative cosine x over sine square x times sine cube x dx. And this is the same as 1 over sine cube x times the negative of cosine x over sine square x dx. So now I can perform the change of variables, my negative cosine x over sine square x dx as du, and my 1 over sine cube x as u cube. So we are basically just integrating u to the power negative 3 du. After evaluating it, we get u to the power negative 2 over negative 2 plus c, which is the same as half times u to the power negative 2 plus c. Last but not least, we substitute my u as 1 over sine x. We get the following, which is half times 1 over sine x to the power of negative 2 plus c. It is the same as half sine square x plus c. And this is the final answer to the integration of sine x cosine x dx. We can solve this problem by using the integration by part techniques with the following formula. We let one of the term as u and the other term as dv. So this is equals to uv subtracting away the integral of v du, in which to find my v I would integrate dv, and to find my du I would differentiate u. So in this case, we'll let u be equals to sine x and my dv be equals to cosine x dx. To find my du, I differentiate u with respect to x. This gives me cosine x, in which multiplying both sides by dx, I get du is equals to cosine x dx. To find my v, I integrate cosine x dx. I basically just get sine x. Once I found my u, v, du, and dv, I can apply the integration by part formula to move on to the next step. I will get the following: my u is sine x, my v is also sine x, subtracting away the integral of v, which is sine x, and my du is equals to cosine x dx. So this is equals to sine square x minus the integral of sine x cosine x dx. And now as you can see, this and this are the same. Basically, we can just rewrite the whole equation as the 2 times of the integral sine x cosine x dx is equals to sine square x, and therefore my integral of sine x cosine x dx is just basically sine square x over 2 plus a constant behind. We can find the integration of sine x cosine x dx using the integration by part techniques. In this particular case, we get u be equals to cosine x and my dv be equals to sine x dx. To find du, we differentiate u with respect to x. This gives me negative sine x, in which multiplying both sides by dx, we get du is equals to negative sine x dx, and my v is equals to the integral of sine x dx, which is equals to negative cosine x. Once I have my u, v, dv, and du, I can apply the integration by part formula to move on to the next step. I will get the following: my u is cosine x, my v is equals to negative cosine x, subtracting away the integral of v, which is negative cosine x, my du is negative sine x. And we get negative cosine square x subtracting away the integral of sine x cosine x dx. And as you realize, this and this part is the same, and hence I can rewrite the whole equation as follows: my 2 times of the integral of sine x cosine x dx is equals to negative cosine square x, and hence therefore my integral of sine x cosine x dx is just basically the negative of cosine square x over 2 plus c. can also solve the problem by using the integration by substitution technique, letting u is equals to cosine x. We differentiate u with respect to x. This gives us negative sine x, in which multiplying both sides by dx, we get du is equals to negative sine x dx. Next, we can rewrite the problem as the negative of integral cosine x times negative sine x dx, and then I can perform the change of variables by substituting cosine x as u and my negative sine x dx as du, in which after that I can evaluate the integral of u du. I will get u squared over 2 plus c. Last but not least, I substitute my u as cosine x, and I get the final answer, which is negative of cosine square x over 2 plus c. We can also find the integration of sine x cosine x dx by first converting the sine x and cosine x into complex numbers. My sine x in this case will be equals to e to the power of ix minus e to the power of negative ix over 2I, while my cosine x is basically equals to e to the power of ix plus e to the power of negative ix over 2. And hence I can convert my sine x into complex sine, which is as follows, and my cosine x as, I will take out the constant 1 over 4i. I will get the following, which is 1 over 4i, the integration of e to the power of ix, subtracting away e to the power of negative ix, times e to the power of ix plus e to the power of negative ix. This algebraic expression resembles like the following, which is a minus b, a plus b. So as you know, when we get this, we get a squared minus b squared. Applying the algebraic knowledge, we get the following, which is 1 over 4i, the integral of e to the power of I 2x, subtracting away e to the power of negative I 2x dx. And this can be further simply split up into two different integrals. The first integral will be the integral of e to the power of I 2x dx, and the second integral will be the e to the power of negative I 2x dx. And then we can perform our integration. So the integral of e to the power of I 2x is just basically e to the power of I 2x over 2i, whereas for the integral of e to the power of negative I 2x, we get e to the power of negative I 2x over negative 2i. And then we can simplify a little bit further. We get the following, which is 1 over 4, and we combine the denominators together. We get just e to the power of I 2x plus e to the power of negative I 2x over 2i. And we factorize the 1 over 2i, we get 1 over a squared, e to the power of I 2x plus e to the power of negative I 2x. And I squared, basically in complex numbers, it is same as negative 1, and we get 1 over 8 times negative 1, e to the power I 2x plus e to the power negative I 2x plus c. Note that from here, cosine x is equals to e to the power ix plus e to the power negative ix over 2. Therefore, my cosine 2x is basically just e to the power I2x plus e to the power negative I2x over 2. I'm making 2 cosine 2x as the subject, we get just e to the power of I2x plus e to the power of negative I2x. And hence this is equals to the negative of 1 over 8, substituting this whole thing as 2 cosine 2x plus c, and then I will have the final answer minus 1/4 cosine 2x plus c. The solutions I've shown today are just some solutions to find the integration of sine x, cosine x, and there are also many other ways in which you can do so. Leave your answer in the comment section below. If you guys like today's video, help me press the thumbs up icon below this video, and do consider to subscribe to this channel for more integration problems. I'm Bob, thank you guys for your support, and I will see you in the next video. Goodbye guys.